So now we're looking at laws of logarithms, which are very similar and related to the index laws that you would have learnt. You would have met them, I think, in Year 8 or Year 9. I know we certainly cover them in Year 9. You would have seen them since, and you're very familiar with them. For example, x to the power of 3 times x to the power of 4 is going to give me x to the power of 7 because I add the powers. That's one of the index laws. So these are the laws of logarithms. So the first one, I'm going to show you how we get it, but for the others, I've just listed them for you here. There's a little bit more detail in your textbook if you want it. So if I start with, let's let m equal a to the power of x and let n equal a to the power of y. If I rewrite those as equivalent statements using logarithms, for the first one, my power x is here and my base is still a, and my argument m is the answer to this one here. So x equals log base a of m, y equals log base a of n. And then what I want to do is find out what happens when I multiply these together, m times n. Well, you know that I'm going to get a to the power of x times a to the power of y, which gives me a to the power of x plus y. Now what I do is I'm going to rewrite this using logarithms. So once again, my base is going to stay a here, and the answer, mn, is going to be the argument of the logarithm, and then the power here is going to be on the other side of the equation. So I've got log base a of mn equals x plus y. These are equivalent statements. If you feel like that's kind of making your head spin looking at that, I suggest you pause now and go and practice just doing a few conversions before you continue, because you want to get your head around the way we convert between exponential equations and logarithmic equations. Okay, so if I've got log base a of mn equals x plus y, but I've already said up here that that means that x is log base a of m and y is log base a of n. So I end up with log base a of mn equals log base a of m plus log base a of n. So this is our first log law. If I have an argument that is multiplied together, then that can be rewritten in expanded form by adding together the logarithm with the same base, base a, base a, base a, the same base, but this m times n becomes log base a of m plus log base a of n. The division, log base a of m divided by n, becomes log base a of m minus log base a of n. Then I have a few more log laws, which I'm not going to show you where they come from, but they're not too complicated to get there. Actually, law 3 I can show you. I will show you law 3. I'll just write it over here. So for law 3, if I've got log base a of m, for example, cubed, you know that we can rewrite that as log base a of m times m times m, where that m times m times m is the whole argument. Log base a of m times m times m. Now using the first log law, I can now expand that and write it as log base a of m plus log base a of m plus log base a of m. And if I added those together, I'm going to get 3 of them, 3 log base a of m. So what actually has happened is that this power inside the argument here has become a constant multiplied by the logarithm on the outside. And that's what happens here with law 3. This power p becomes a constant multiplied by log base a of m. Okay. Law 4 is a specific case of law 3. When my m is a power of -1, I'm going to get a negative log. And then law 5, this is really just some key logarithms that you should know. Log base a of 1 is always going to be 0 because